Velocity of car is 72 km per hour. Initial distance is equal to 500 meter. Distance of the car from the gun when hit is equal to what? Speed of projection of shell is equal to what? Okay, the initial distance is 500 meter. The bullet is fired at an angle of 45 degree. The car is also running and the projectile reaches at this point and car also reaches this point. Okay, the time of flight is 2u sine theta by g and horizontal range equals to this much. Since theta equals to 45 degree, we get horizontal range is equal to u square by g. When the projectile from point O reaches this point, hitting point, the car also reaches there. That means this 500 plus this term v car t is equal to horizontal range. That's why we can write according to question r equals to 500 plus velocity of car times time of flight. Okay, let's substitute the values. The speed of bullet we get 85.56 meter per second and you can get horizontal range as 746.9 meter. Okay, here is another question. Two bullets are fired, one horizontally and one vertically, making angle 60 degree. These two bullets collide at this point. When they collide, x1 equals to x2 and y1 equals to y2. Okay, this is first bullet and this is second bullet. For first gun x1, this x1 is equal to horizontal velocity into time and y1 equals to 10 minus half g t1 square. For second gun, x2 equals to the horizontal velocity. The horizontal velocity for second gun is 5 root 3 cos 60 degree t2 and y2 equals to this much. Okay, for collision of sorts, x1 equals to x2 and y1 equals to y2. On solving, we get t2 equals to this much, t1 equals to 1 second. Now substituting values, we get this coordinate for xy is 5 root 3, 5. A projectile is projected at 10 meter per second by angle 60 degree to horizontal. After some time, its velocity makes an angle of 30 degree to the horizontal. Find its speed at this instant. Okay, the bullet is the initially projected. The bullet, or let's say projectile, not bullet. The projectile is projected at an angle of 60 degree. Okay, now this is horizontal component and this is vertical component. After some time, the velocity is making angle 30 degree to the horizontal. That means this horizontal velocity is making angle 30 degree to the horizontal. Here, the most important point here is that the horizontal velocity is constant. We equate horizontal velocity. The horizontal velocity remains same. That's why we get v equals to this much. Okay, here is hunter and here is monkey. The horizontal distance is x. Here is monkey at height s from the ground. It fires bullet at an angle theta with the horizontal. If there is no gravity, this travels in this red path bullet, but there is gravity. Okay, this is horizontal component and this is vertical component. Okay, the monkey travels this much distance when bullet is fired. This travels half g t1 square. Okay, the bullet follows parabolic path due to projectile hitting the monkey. Okay, this is the height of monkey. Okay, if there were no gravity, s equals to vertical velocity into time. That means time equals to this much. There is gravity. That's why this y equals to ut plus half at e square. We get this much u sine theta t. This u sine theta t is equal to h. Bullet will hit the monkey if this y is greater than 0. Y is greater than 0. Let's substitute the values and solve it. H minus half gt square is greater than 0. H is this much. Okay, okay, now from figure, hypotenuse equals to x square plus h square, cos theta equals to this much. Okay, now we get u equals to this much. Okay, if u is less than u naught, the bullet will hit the ground before reaching the monkey. When does the bullet hit the monkey? The bullet is aimed at monkey's initial position. The monkey starts falling exactly when the bullet is fired. Gravity acts equally on both the bullet and the monkey. When does the bullet miss the monkey? The bullet hits the ground before reaching the monkey. Speed is too low. The bullet is not aimed at the monkey's initial position. The monkey does not start falling at the instant bullet is fired. Okay, there is aeroplane flying at an angle of 23 degree with horizontal at an angle of 90 meter per second above the horizontal. At the instant, the plane is above 114 meter above the ground. A, a briefcase falls from the luggage compartment like this. Okay, reaches end point B. Okay, this is origin. For this direction we take positive, this direction we take positive, and this direction we take negative. That's why our h is negative, horizontal velocity is positive, and vertical velocity is also positive. Okay, since this h is below the origin, we write minus h. uy, this uy vertical velocity is above the origin, that's why we write plus, and ay is always minus g. Now let's substitute the value, then solve it. We get t equals to this much. The negative value is discarded. R equals to this much. 782.06 meters.